Good morning and welcome to Into the Terminal, episode 5. If you're watching this asynchronously, this is actually our third attempt to kick this episode off successfully. So, if you are watching this after the fact, try and make it live, because you never know what's going to happen between house alarms and crashing lab environments. It's great. But anyway, my name is Eric the IT Guy Hendricks, and joining me today is Mr. Scott McBrien.
Hello, and don't forget, we're professionals.
Right. We work in the business unit for this stuff. We're supposed to we're supposed to be the experts. All right, so what we're looking at is Scott McBrien's home lab here. So be sure to jot down any IP addresses or whatnot, just to make sure that you can sneak into his network after the fact, because that would be about par for the course today. So the first 4 episodes we've covered commands and system operations that are all local to a single machine. So today we're going to switch things up a little bit, and we're actually going to connect from Scott's local system that we're looking at now to a remote system. So whether that's a laptop on your desk out to a cloud instance, or into your data center, or even a virtual machine local on your laptop or your desktop. We're going to cover 2 main commands today, and they're going to connect us from local to a remote system. The first one that we want to take a look at is SSH. SSH is a secure tunnel-based protocol that allows you to send traffic from a local system to a remote system, encrypted. And I don't know if you were typing into the terminal, but I'm not seeing SSH up there. There we go. Okay, so we're going to connect to the IP address of a remote Linux system here, and what that does is that allows us to connect from our current user to a similar user on the remote system. So when we connect to the IP address or to the host name, it'll prompt you for a password. Type in your password, and then as you can see, Scott's got some relevant information that shows him what system he's using, what operating system version, and there's different ways you can customize that particular feedback. But if just by looking at this, we can kind of get an idea of what system we're working on from here. So any commands we run in the terminal from here on out are going to be on the remote box. But if we type in exit, or if we type a Control D on the keyboard, that'll actually bring us back to our local machine. And we'll do a little bit more remote here in the second segment. But the second command we wanted to cover at the top of the show is SCP. While SSH allows you to send commands to a remote to actually connect to and be on a local machine, or on a remote machine, I'm sorry, SCP actually allows you to send files, or to push or pull files from a local to a remote machine. So Scott's got some JPEGs, some image files here that we want on our remote Linux box. So maybe that's maybe we're trying to send files to a web server in some cases. So what we'll do to do a push is we're going to type SCP, the name of the image file in this case, the IP address or host name, and then if we do a :/ and then the path, we can actually tell the remote box where we want this file to live. So again, it's going to prompt us for our password. And you'll see that 100% of that file was copied. It tells us how big it was, how fast it was transferred, and if this was a larger file, that last column there, the 4 zeros, would actually tell us how much time remaining in the file transfer. So if we go ahead and SSH back to our remote machine, and then do an ls on temp, we should be able to see our image file. Yep, right there it is, 1278. And then once again, if you hit exit or Control D on your keyboard, that'll actually bring you back to your local machine.
So one of the other things we can do, Eric, is not only push files to a remote machine, but we can also copy files down from a remote machine, right?
Yes. Great point. I actually forgot that. Oh, this is going to be a great episode for bloopers. So, what we showed you at the top of the show was how to push from your local machine to a remote machine. But if you're working off of maybe a file server where you've got a bunch of files, or you want to pull maybe a backup from a remote machine and pull it down locally, you use the same command, the same SCP. The syntax is just basically reversed. You list the remote machine and the file or directory, and then you can hit a space and define a local path, like the home directory that's got indicated with the squiggly line, or it's not the tilde.
Tilde.
I forget what it's.
It is
Is
the
it a
tilde.
tilde? Okay, good. I second guessed myself, and I shouldn't have. But let's add a little bit more complexity to this, and let's add in the -r argument. So what we did at the top of the show was moved a single file from a local to a remote system. You can actually move entire directories at one time with one command. So you don't, if you've got 50 files, you don't have to put in your password 50 times. So by doing the -r or recursive argument, we can actually pull down the entire instruct folder to our home directory. So if we go ahead and hit enter, it'll prompt us for a password, and it will start that file transfer. So it's pulling down Markdown files, YAML files, a few scripts, some PNG image files, and it's pulling all of that down to our local system. So instead of having to type in our password, I mean, what was that, like probably about 40 or so files, I personally don't want to put in my password that many times, and definitely not type it in at all if I can help it. So if we do an ls on the instruct file, or on the instruct directory, we'll see all of those files that we just pulled down. But I don't know about you, Scott, but I don't like typing in my password that many times, especially if I'm a systems administrator and I've got several hundred servers and I'm doing different tasks on different boxes. Is there I'm guessing there is a way we can maintain our security, but also bypass that password operation.
So yes, but I think what you're alluding to, Eric, is key-based authentication.
Yes.
But when we set a SSH key, typically we will provide a passphrase in order to be like a two-factor authentication, right? We have the key file with the key contents, but then we also have the second factor of the passphrase in order to use the two together. And that's probably the most recommended way of setting up key-based authentication for SSH.
That's a great point. Having that two factors is incredibly helpful. To be honest, here in my local lab, I actually don't use password encrypted keys, but that's just because nothing on the internet can get to my lab environment. So that's a great point to point out. A great point to point out.
So
we're doing great.
I would further point out that there's a lot of agents, like SSH agent, for example, where you will type in that passphrase a single time and then it'll cache it. So for your entire desktop session, you won't have to re-enter it because it's cached in this agent that holds it for you. So while it might be irritating to have to type in a passphrase to go with your key, there's a lot of other things that you can add to your SSH ecosystem to ease that, but still maintain your more strict security model.
Awesome, that's a great point. I'd actually forgotten about SSH agent. So let's go ahead and let's build a key. And you want to walk us through a couple of the arguments that, or the SSH keygen command is almost like a wizard that goes through and asks you a number of questions. But you want to walk us through what it's actually doing?
Sure. And I think that what I'm showing you is probably a scenario that's consistent for a lot of people, where you are using one operating system for your desktop and you're interacting with systems somewhere else. So what we're looking at is actually the Bash shell of a Mac, and then we've been using this Mac to connect to our Linux box out there in the world. So I'm using SSH Keygen, and that's a command that's pretty much ubiquitous across SSH implementations. It's going to create by default an RSA um, key pairing. So there are several different um, algorithms or ciphers that you can use for generating your SSH key pair. RSA is probably one of the more standard ones, and that's why it's the default. So it's asking you where to save the key. And by default, SSH Keygen will create a directory in your home called .ssh if it doesn't already exist. And then it's telling you it's going to call that file that's creating ID RSA, and it's giving you an opportunity to override that default now and call it something different. So if you have a more complex layout where you have different keys for different hosts, or you have multiple keys that you want to use for a user account, this is a place where you can um, decide what you want to call it. I'm just going to take the defaults. So I'm just going to hit enter. All right, then it asks for the passphrase. So this again is like the second factor of authentication. You can set up so that you can copy the key to your remote host, and just by having the key, you can present it to that remote host as your authorization or authentication mechanism. But having the key stored locally encrypted with a passphrase means that if somebody is able to get that file that stores the key, they can't use it unless they also have the passphrase. So generally, it's recommended practice to set a passphrase. Okay, so at this point, what I've got in my .ssh directory is this. So I've got my ID RSA, that's the private side of that key I just created, and I've got ID RSA pub, which is the public side of that RSA key pairing I've created.
And we definitely don't want to undersell the importance of keeping that private key secure. That's not something you want to publish to a Git repository. That's not something you want to email to a coworker. That's the purpose of the public key. So keep that that ID underscore RSA file as secure as possible. But the public key is the one that you share out to make the other part of that handshake.
So the next part of
Okay, so
setting up key-based authentication is taking that public key and putting it on the host that you want to use key-based authentication on. So let me see if we have, yeah, copy ID. Um, so SSH copy ID is a command that will copy your SSH key, your public key, to a remote system. All right. In order to make the copy, it's actually using SCP behind the scenes. So you have to log into the remote machine to complete the copy. And what it did on the remote machine was it took that public key and it added it to the remote machine into a file called authorized keys. And essentially, what that means is if I connect to that machine now, it will present it'll present the public key. Let me get this right. It'll ask me to send some credentials that have been encrypted with the public key. So they send a piece of data that's been encrypted with the public key. I unencrypt it with the private key, make a change, re-encrypt it with the private key, and send it back. And then it unencrypts the data again with the public key and validates that the change was made successfully. And so I'm not exposing the private key anywhere. I'm simply using it as part of our asymmetric encryption to encrypt and decrypt data that's been sent to me that's been encrypted with the other side of my key architecture. And what that allows the systems to do is verify that I hold the private key that matches the public key that was used initially for validating my identity. So that's what we're doing with key-based authentication. The end result is that I'm basically let into the system. So, right. So it has sent me the challenge that's been encrypted with a public key. In order for my local system to validate that challenge, I'm being asked to put in the passphrase for my private key so it can be unencrypted and used. Oh, maybe I forgot it. And then once that challenge is sent back with the correct data, I'm let into the system. All right, so this is my remote box.
Okay, so that is a quick look at how to add additional layers of security to your remote connections, especially if you're going out into a box with a public IP address, something that's reachable from the internet. This becomes even more critical. But we can actually dive in another layer down and add some additional requirements to our SSH server uh, to uh, to further require I don't want to say hoops to jump through, but basically to further require certain parameters to be met. So within the Etsy directory, and Etsy is where a lot of our configuration files for the entire system live, there is an SSH directory, and the main file that you're going to be interested in is this sshd_config. So if we go into that file, there'll be tons of arguments and comments on what those arguments do. So if you're new to configuration files, anything with the pound or the number sign at the beginning of it is a comment and won't be read by the system during execution. But there at the very bottom where it says host key, you'll notice there isn't a pound sign there. So that is actually a line of code that that the system will read upon reading this file. So first thing I wanted to mention in the sshd_config file is there is an option called permit root login. And what that does is we can actually disable, and most operating systems have moved to having the disabled by default, is permit root login, which means can I SCP or SSH to the root account on this box. So in this example, we're on Scott's remote Linux machine right now. And so if that's set to no, then from Scott's MacBook, we can't SSH via root or SCP via root. We'd have to have a different user with the appropriate credentials. Now, like Scott here, I've actually, for my jump box only, I've got a box that I remote into that gives me access to the rest of my lab. I've actually turned that back to yes. But in a production environment, you definitely want to disable permit root login, or I guess, yeah, you want to disable permit root login. I said that backwards. Then the second thing I wanted to point out about this file is you can actually disable password. You can actually disable password logins. So let me slow down and explain this carefully. You can, like we did at the top of the show, log into a remote system using a password, and that's well and good. But the idea of security is you need to be more secure than the guy standing next to you, because you're never going to be 100% secure. There's always going to be some vulnerability or some misconfiguration out there. So the more things that we can do to ensure that our systems are secure, the better. So this password authentication option actually can disallow the password-only login that we showed at the top of the show. So you can't just SSH into a remote box, type in your user password, and get connected. Instead, what this does is this forces the use of keys. So we created a key in the last step, and we now authenticate the key as opposed to authenticating to the user. So by disabling password authentication, it requires keys to connect between systems. So this just adds yet another layer of security. And if you think about it, you're not adding any additional requirements on the side of the user beyond just having a key on the on the remote system.
So I would like to point out that by toggling this to no, having that key file is critically important, because if you were to lose your ID RSA, right, which is your private key file, you would now no longer be able to log into this host if this host is configured to do key-based authentication only. And you'd have to physically go to it and log into it in order to reestablish that, right? Because we've done two things. One is we've disabled root access, so you can't connect to it as root anymore. And secondly, if you've lost your key, then you can't connect to it as you anymore either. So we'd have to find out. We'd have to find the box and physically connect to it, or use something like a remote access technology like ILO or DRAC in order to connect to its console. And I see that Eighth Doctor points out that the default with Red Hat Enterprise Linux 9 is changing. So Eric and I went through and disabled root access. That will be the default for RHEL 9. So for RHEL 9, there will be permit root login no by default in this file.
So, harkening back to our episode yesterday about managing services, making these changes, and if we do a write on this file, doesn't actually change anything at this time. So, if we do a write and then we're back at our prompt, we actually need to restart the SSH service in order to put those configuration changes into effect, or reboot our system. So let's just do a systemctl restart SSHD, and so that D stands for daemon. So it's the SSH daemon that we're actually restarting here.
So Eric, quick question: I'm SSH'd into this box, which means when I restart the SSH daemon, where it stops it and then starts it again, what happens to my session?
Well, I dare you to hit enter and find out.
All right, so it turns out that SSH is really good at preserving open sessions, so or reestablishing open sessions. So even though we restarted the daemon, I was able to reestablish my existing SSH session. However, a restart is a stop followed by a start. So if I had bungled my configuration file badly enough, it could cause the daemon to not start back up again, which would then make it very difficult to reestablish those open connections. So whenever you're working remotely, keep keenly aware of those things that can affect your ability to contact that box remotely. Nobody wants to drive to the data center at 4 o'clock in the morning.
All right, so Scott, do you have anything else about SCP and SSH that you wanna mention before we move on to the last point for today?
So the last point for the day, I actually need to check to see if I've got it. I may not have it, in which case we'll just have to talk about it. But I just wanted to validate that our changes were accurately applied. So if I SSH this box and put in my passphrase, right, we're good. Right, did key-based authentication.
We've made your lab environment more secure today. You're welcome.
And if I try to log in as root, right, I'm not allowed to log into the box as root because we changed that permit root login to no. All right, and then lastly, if I move my key file, right, so I moved it outside of its normal place, so we shouldn't be able to find it when we're doing authentication. All right, notice I'm not allowed to log in because we also disabled password-based login for this system. Just go ahead and put that back so we can get back over there.
So while Scott's checking on our next example, I did want to point out that Eighth Doctor brought up a good point in the chat that with the SCP command, you can actually have multiple sources into a single destination. So if you have multiple files from different places, maybe you've got something in a home directory and a file share, and maybe a backup directory, so 3 or 4 places, you can actually SCP those all into one destination. So that was a great point. Eighth Doctor was just you don't have to do one-offs in your commands. You can actually move multiple files into the same remote or local destination. So the last utility we wanted to cover today was a lifesaver when it came to being a systems administrator. I routinely had upwards of 2, 3, or even 500 boxes that I was responsible for, and you never know when you need multiple different terminal sessions on a single box, or you're connected to multiple boxes trying to execute operations. Especially trying to troubleshoot connections between one box and another. And so what we've been looking at is a single terminal to a single system, whether that's the local system or today we talked about remote systems. But sometimes that's just not enough. And there's a utility. There's several of them out there, but my preferred it's called a multiplexer. My preferred multiplexer for for the terminal is actually called Tmux, which is short for terminal multiplexer, because we're incredibly creative in the open source technology world when it comes to naming. So what we're looking at is the same terminal we were just in, but what we've added now is the ability to open up multiple sessions on the same screen. So if you want to maybe open up a horizontal pane.
And what would be the command to do that, Eric?
That's a great question. I don't remember what it is out of the box because I have a custom Tmux configuration file that lives on all of my systems that changes that.
So I also don't recall it off the top of my head. How about we just talk about disconnecting and reconnecting?
Okay. So what we were trying to demonstrate was that you can hit Control and another key, and it'll actually. Okay, so Eighth Doctor says it's Control B and in. I was hoping Eighth Doctor would bail us out again. Oh, I guess not. Anyway, so what you can do is you can actually open up multiple panes within this screen. So if we were trying to troubleshoot a connection between our local system and our remote system, then we can actually split this out and have multiple panes. And so what that gives us the ability to do is if we're trying to run the same command on multiple systems, we can do that from a single screen. But then what Eighth Doctor is alluding to is that we can actually create multiple windows within this session. So one area where I've used that in the past is having one screen for my dev environment, having another screen for my production environment. That way I can kind of very quickly, with just a couple of keyboard shortcuts, bounce back and forth between the two and say, okay, this is working in dev, but it's not working in productions. And so I can quickly, with just a couple of keyboard shortcuts, get around to my entire environment. Now, as Scott and I were pointing out, there is a .tmux.config file or .conf file that gets created when you install Tmux on your system, and you can customize it. You can customize keyboard shortcuts. You can customize colors. It's a very, very configurable utility that really saves you time and effort when you're administering a lot of systems.
So I would like to point out that, like all technologies that run on top of Linux, we can get so far down the rabbit hole on Tmux that it would be indescribable for someone new to the system. Our target audience for this program is people new to Linux. So let's up level a little bit and talk about why we care about Tmux. So Yes, you could do crazy, complicated things with Tmux to customize how you view different systems, yada, yada, yada. Let's put that in a box for a minute. Um, the goal of Tmux is to allow you to create a standalone session running on the system. Right? Remember that this is a system that is remote to us. And so what happens if there's a network blip between you and the system while you're running some program? Right? Typically, what would happen is that blip would close your connection, which would kill off your programs. Right? So by having Tmux, you're having a standalone session that can survive disconnections. So here I've created a Tmux session. It has created a shell for me, and I can do a long running job like a device to device copy. Right, and it's going to run. This is actually going to run forever, but at this point, I could have a network outage, or maybe I'm just going home for the day, and it's time for me to log out and take my system with me. So let's disconnect from our session. And Eric, do you remember the command?
I don't remember if it's the default, but it's Control B and D to disconnect.
Correct. So notice when I hit Control B and D, I return to my session, my original session, and it gives me this message that I've detached from Tmux. All right, detached is important because if I look at PS, one of these bashes is actually the one running in my Tmux session. Let's see if Tmux is here. Yeah, so it is also still running, right? So I'll go a step further, and I'll close my SSH connection to this box. All right, and if we go back to the system, that Tmux session is still running, which meant that that shell where I was running that command is still there. And most importantly, I can get back to it. I think it's a 0 if I'm right. Is that correct?
You can do just a Tmux A, and that'll connect you to the most recent session.
Okay. So I reattached to my Tmux session. Notice my command is still running here, right? Fully protected from the disconnection, from me even leaving the machine. It's still there, and I can resume it later.
Yeah, this is Tmux is an incredible tool, and it really allows you to survive network blips, or if you're troubleshooting something and you need to get home for the day. It's great to just detach from a session, just leave everything exactly where it was, and then come back to it when you log back in. All right. So if my math if my math is working out, we're pretty much close to time. Maybe a few minutes over. So as you can tell, joining us live, you never know what's going to happen. There's always something fun that threatens to derail the entire episode. But be sure to like and subscribe. Tell a friend. We are working hard to keep this high level. I know between Eighth Doctor, Scott, and myself, we could probably do an entire episode on Tmux by itself. So we're going to try and keep this high level. But we did have a scheduling change. Scott, you want to address that real quick?
Yeah. So as you all know, we do a dark mode edition of this show as well in the evening U.S. time to pick up some of our friends either on the West Coast or internationally, where this time may be inconvenient for them. And Eric and I realized that tonight, on Friday night, I will be running a dark mode for people that may be watching on Saturday morning. So we decided that Scott spending his Friday nights doing dark mode into the terminal is probably not what Scott wants to be doing with his time. So going forward next week, we will have dark mode tonight, but going forward into next week, we will not run dark mode on Friday evenings.
The morning episode will be available on our YouTube channel, so you can catch all the fun after the fact. And the link that you use to get here will be the permanent link. So it's not just for the live stream. You can come watch this over and over and over again, and watch Scott and I fumble through trying to figure out what default commands are in Tmux. But also wanted to point out the fact that next week is what we're calling Jumpstart Week. So what it is pretty much all of these episodes are fairly Linux generic. A few Red Hat Enterprise Linux specific things, but next week is going to be all Red Hat Enterprise Linux all the time. So we're going to walk through getting signed up with a developer subscription, getting the RHEL 8.x ISOs, and yeah, Scott is pretty funny in third person. And then we'll talk about how do you get from not having any Red Hat Enterprise Linux at all to having a running system where all of the examples that we've shown you this week and in the weeks to come, you can do on a Red Hat Enterprise Linux box for yourself, or in a cloud or company environment. And then we had one other announcement that we wanted to point out. Red Hat Summit is coming up in May 10th and 11th. It's going to be predominantly a virtual event, and registration opened up as of yesterday. So if you're interested in catching keynotes, some live events, and as well as some cool sessions about what's coming with Red Hat Enterprise Linux or some of our other products like OpenShift and Ansible, you can go to, I think it's red.ht/summit, and you can get registered. More to come on that as we get a little bit closer. But other than that, it's been an awesome first week. We're 5 episodes in. We only had one that fell off the rails entirely, but I'm looking forward to bringing another week of daily shows next week.